Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through transformations and congruence. So let's start with transformations, and there are three that you would have learned last year. They are translation, reflection, and rotation. Let's take a look. So let's say we have a random shape like this, a triangle. We're going to translate it, reflect it, and rotate it. So let's start with a translation. So a translation is just a slide. I'm going to take the shape and simply just move it over. So there you can see that I have the exact same shape, it's just been moved across. So now we're going to look at a rotation or turn. So I'm just going to take the original shape and turn it. So hopefully you can see I've taken the original shape and I have just turned it to get the shape that is there now. So the last one I want to go through is a reflection or a flip. So a reflection or a flip, it's like we have a mirror line and we reflect it about that. So this vertex goes down to here, this vertex goes down to here, and the other vertex goes down there. So this is the exact same triangle, but it has been flipped over. It's like the bottom one is a mirror image of the top. Now, if I were to just give you all these triangles, it would be very hard for you to try to figure out which transformation had been applied. Particularly if the original shape had reflectional symmetry. So reflectional symmetry means that I could, say, divide it in half with a line like that. So if it has reflectional symmetry, that actually means that you can get a shape like this from either a reflection or a rotation. So it's very hard for you to figure out which of the transformations has been applied. So whether or not it actually has this symmetry, to avoid any ambiguity, we want to label the vertices of the original shape. So the original shape is called the pre-image, and each of these shapes that occurs after a transformation has been applied is called an image. So the vertices of the original shape are just normal letters like A, B, or C. And what we do is we put a dash on them to indicate that it's a vertex of the image. So this would be A dash, C dash, and B dash, okay? So you can observe which transformation has occurred by observing what has happened to the vertices. So A, B, and C, all the vertices have just been slid along. That's how I know a translation has occurred. In the shape down here, if I label this A dash, B dash, C dash, it's much clearer that a rotation has occurred because I can see that the vertices have just been rotated. So B was at the top, it's moved to the right, A's moved to the top, and so on. So that is clearly a rotation that's occurred. So if I look at the image now on the bottom, I call it A dash, C dash, and B dash. The vertices have been reflected, so I know a reflection has taken place. So why are we learning again about all these transformations? Well, it turns out that if I translate, rotate, or reflect a shape, as I have done here 3 times, it doesn't change the shape. The image is exactly the same size and shape as the original. So each of the images has the same side lengths and same angles. It is the same shape, but just a different orientation. It's just positioned slightly differently. And that's what congruent actually means. So congruent essentially means that the shapes are the same. So 2 shapes are the congruent if they have all the same sides and they have all the same angles. Essentially, they are the same shape but in a different position. So when you translate, rotate, or reflect a shape, the image is congruent to the original. It is the same size and shape as the original. So we're now going to look at this in a little more detail. So here we have two triangles that I'm telling you are congruent. So we need to know how to write a congruent statement. So what we have to do is we have to line up each vertex in the pre-image with its vertex in the image. So hopefully you can see that because there's a right angle at B and D, these two vertices correspond to each other. Now the way I got the second triangle was just rotating the first one. So I have E and C correspond to each other, and then A and F will correspond to each other. So if I want to write a congruent statement, I write it like this: triangle. I can call the first whatever I like, so I'm just going to call it ABC. Then I use this symbol here, 3 lines. So that means congruent to. So it says triangle ABC is congruent to triangle. Now I have to put F first because it corresponds to A. D corresponds to B, so it goes second because B went second. And then E goes third because C went third, and they correspond. So these two triangles are congruent. That's how you write a congruent statement. So if they are congruent, that means they have all the same sides and all the same angles. So that means if this side here is 8 centimeters, then this side here will be 8 centimeters. If this side here is 11.314 centimeters, its corresponding side, so that would be, so F corresponds to A and E corresponds to C. So FE corresponds to AC, which is this side here. That would also be 11.314 centimeters, okay? So because I told you they're congruent, there are pairs of equal sides and pairs of equal angles. So you just have to figure out which sides correspond to which angles correspond to which, and which vertices correspond to which, and you figure that out by figuring out has a reflection, rotation, or translation taken place. So that's all we need to know for this lesson. I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.